The overall goal of this procedure is to allow for the examination and characterization of the contact substrate and contact nanowire interfaces for single gallium nitride nanowire devices. This is accomplished by first preparing a nanowire suspension and dispersing it onto a substrate. The second step is to deposit the nickel-gold contacts on the nanowires and then anneal the sample. The final step is to remove the annealed nickel-gold contacts from the substrate by adhering them to carbon tape. Ultimately, a scanning electron microscope is used to examine the contact interfaces for void formation.
This method can help answer questions about how to process semiconductor nanowires. In particular, it gives us a way to assess how well the metal contacts are sticking to the nanowires and to the surrounding substrate.
Visual demonstration of this method is important because the nanowire dispersal and film transfer techniques can be difficult to learn, as the small details of handling and placement can have a large effect on the yield.
I was looking at the sample with an SEM when I noticed an area of the metal contact had started lifting up away from the substrate. When I looked at it closer, I noticed the underside of the contact had this very unusual morphology. So in order to get a better look at the underside morphology, I developed this technique.
To begin, cleave a small piece of the as-grown gallium nitride nanowires on a 111 silicon substrate and place it into a small vial with 1 milliliter of isopropanol. Sonicate the vial for 30 seconds in order to remove the nanowires from their anchoring substrate. Then, clean a silicon wafer by submersing it face down in acetone using a tripod holder. After 5 minutes, remove the wafer from the acetone.